Okay, I want to talk about the coming up lab next week. There's a number of things different. For next week's lab, are moving off the ARM board a little, and we're going to be playing with the ESP8266. It says follow the week 8 ESP8266 AT documentation to set up the required hardware and software, and using the TCP IP AT examples. Example 1 as a guide: connect to a packet server on someone else's computer, send a hello first name to the server, and receive it from the TCP server. Upload a screenshot of the sent and received packet to the assignments folder. And there it's just showing you where the TCP IP examples 1 is kind of where you need it, and that's over at Espresso's documentation website. Okay. And so it says refer to our week 8 documentation. So this one should be up there as well. So the ESP8266, is, for instance, that little module that we have. That's one of the devices you have there. So that's the ESP8266. And we were talking a little bit about it last day. The little board that's soldered on top of the board here, you can buy by itself, and that's called an ESP8266, like 12E or something like that. This whole carrier board is known as a Node MCU, and there's a few different variations of the Node MCU out there. So you always have to look and say, okay, is the one that I have, was the printing and all exactly like the one that I'm looking at documentation for? There's a few out there that have a few extra pins, for instance. So you always have to just look and say, okay, is this the one I'm referring to? And this, again, you can go and buy this ESP8266. This one's a 12E or 12F. Just talks about the amount of memory and things that are on it. Under this CAN, there's the ESP8266 chip, and there's a serial flash memory that it uses to go and run it. And depending on the one you buy, it might have 1 mega flash or 2 mega flash, 2 megabit, or up to 8 megabit. I think there might be a few others. And so it runs all its code off that flash that's outside of the chip, but all underneath this CAN. And this is all to do with conforming to radio emissions and all of that. So this little guy is, like I say, about $3. This little guy, you can get the whole Node MCU is about $12 or so if you order it and wait a long time from China and things. One of the advantages that it gave us was it's a little hard on this small chip to be able to access some of the controls. And there are versions of it that just have 6 pins sticking straight down, so not all the I/O is pinned out. Then you have to have some other method of programming it. You put it into a bootloader mode and you upload your code. And with the Node MCU, it just does it all through the micro USB connector. And there's a couple of buttons. There's a reset button, and then there's also a boot mode button. And depending on how you program it, you might have to power it up or hit reset and hold the boot button down and things like that in order to make it all run. To put it into programming mode. By default, it's not in programming mode. So in an upcoming lab, we are actually going to program this because it is a microcontroller. It's a single core 32-bit non-ARM based microcontroller. It's a 10 silica processor, and it's by the ESP guys, which is a company called Espresso. And that's where we're going to look at some of the things that they do. One of the cool things that they have had, and before it really took off in the hacker kind of community, maker community, is the fact that they were first this small accessory to other microcontrollers to get Wi-Fi connectivity. That's what it was for. And in fact, when it was kind of first discovered. There's 8266, there was an 82, I think maybe 65 or something like that before, and just somebody saw it, and there was um, just Chinese documentation. The company wasn't thinking about being standalone at all, and then they started saying, "Hey, we can put Wi-Fi," and then, "Hey, it's an actual processor, and if we could figure out the development tools, we could write our own code for it and just use it standalone for a lot of cases." And then again, last time I was talking to you about, if you get a smart plug or a smart light or something like that, chances are it's probably got one of these in it. There are a few other companies that make it, but those, it's hard to beat the price and to be able to get something online. Well, when they first came out with doing all of this, they needed the other processor to talk to it and do something with it. Well, since it's just a microcontroller that has this Wi-Fi connection, they put a command set in called an AT command set, and it's very similar. You'll see an AT command set, for instance, sometimes to talk to GPS units, to talk to various things. There's other Wi-Fi modules, and it comes back from the old Hayes modem days, way back when you used to have to, dial your phone and then put your phone in a cradle and connect up to bulletin boards and things. And the modem, Hayes modem, responded to AT commands. And typically I go AT, and the modem will come back and go OK, meaning I understand you, you're connected all right, and you can do things. So I could change the baud rate, I could dial a number, I could do all of that by just commands that we type in. Same thing here. I can just send ASCII characters to this module as long as it had that firmware in it, and it will respond back and say, okay, it will tell me its version number, it will let me set up an internet connection, it will then let me send packets just by typing things in. Well, once you have that going, then you could plug in another microcontroller to it and have the other microcontroller send those AT commands and have things happen. So it's a way of getting Wi-Fi out on the system. So that's how they first started out. It turned into a whole other thing for them, but they still have this and support this kind of method. And the AT commands, like I say, are used in other wireless communications chips, and they're used in GPSs and a number of other things. So I thought it would be interesting and low level for us to actually go and put some things out on our in the internet from machine to machine. We're going to have to start talking about how all of that happens. When I say TCP, what is it? UDP, what is it? We're going to talk about all of that stuff in the coming up weeks. Okay. And so, first thing, there's actually, for a long time, there wasn't a lot of support for other microcontrollers for the AT command firmware. The Arduino folks have a little module that has Wi-Fi built in, and it's generally it's got a little chip from a company called U-Blox. Well, inside the U-Blox chip is depending is a ESP8266 or ESP32, and it runs a firmware called Nina, which is different from the AT command set. It still does serial commands. That's available as well. I can put Nina on this, and where I say that is when we go and look at the Arduino interface, there are examples that run on the Nina firmware, and there's examples that run on the AT firmware. And I just need to make sure that I have the right examples so that we're talking the same language. Okay, so that's the a little bit on the ESP8266 and the AT firmware. So if you go to espressive.com, there's documentation, and they have the latest AT firmware. Now, this is known as the ESP8266 with the node MCU, and this is the ESP32's node MCU. So they're a little bit more money. This is, where this chip by itself in this little module is probably $3. This one's probably $5, $6, something like that. Now, what this one gives you, an ESP32, it gives you dual core, and I mentioned there's actually three cores. There's three cores. There's a low-level core that's there as well to just take up as minimum power as you can and do some minimal things while the other cores are sleeping. But the big thing is it also gives you Bluetooth, whereas an ESP8266 is just Wi-Fi, okay, and single core and Wi-Fi. But I have the same kind of firmware on this one that I do on the ESP8266, except it doesn't do any of the Bluetooth, or this one doesn't do any of the Bluetooth stuff. So there are some commands there that if I tried to implement it on this, it goes, I don't know what you're talking about. Okay, so those are the ESP32s. Now, so it says download and unzip the latest AT firmware. So I have to go find the latest AT firmware, and it says what is ESP8266 AT, and the hardware connection and the downloading guide, and a whole bunch of information on that. There's the link to go over to Espressive, and it says release. The latest release is version 2.2 ESP8266. And so if we look here, that says ESP8266 binaries. Now, it gives you this links to the source and things as well, and their whole software development kit and their whole compiling. You could download the whole tool suite, get all their source code, change it how you want it, and then recompile it and build your own custom version of the binary and things. And they give you options to do all of that. And what we're just going to do is take their latest binary, and it's compatible with the examples that we're going to do after this lab, and utilize our Arduino sketch interface and be able to use some examples there. Now on this site here, Espressive, and it says download AT, support download AT. You'll see there's a bunch of ESP32s, and there's different versions. There's the C3, there's the S2. The ESP32, they've come out, they originally had just the ESP32s, like the Rover and Room. In fact, what this is a Room version, and then they've come out with a bunch of different modules. The ESP32S series isn't dual core, it's single core. They said, we'll make it cheaper, save some money, maybe you don't need dual core and that kind of thing. So that's ESP32. So we have an 8266 we're going to put it on, so you got to make sure that that's the one that we're going to be looking at. And so if we look down here, there's an ESP 8266 AT, the latest one there. There's also a version 1.74. The 2.2 works fine. When they first came out with it, a number of the different examples worked with the old one better. There were some changes in the AT command set that made some of the things not work, but everything I've seen currently is working at that. But if you had an example and it wasn't working on 2.2, you could always put 1.74 on your unit. And again, we have the ESP32 Room. And so this is kind of our Room form factor. There's a Rover form factor, which generally pulls out a little bit more. It's a little larger board. And any of the Node MCU ones, you'd be looking at a Room. And so the latest version, and it says even recommended, is a version 2.2.1.0, and you just download that zip file. So then download and unzip the flash tool. And so on Espressive, there's under support, there's flash tools. And if you just look at Espressive flash tools or what have you, it's a Windows flash tool. And you generally, in making this happen, you have to plug in your micro USB with the flash before you have the flash tool going. Hold the bootloader button and plug it in, and that puts it in a mode to say, hey, I'm waiting for data for you. And then you run this flash tool. And the flash tool has, we want to be in our developer mode. If you click factory mode, you can go over and have a look. It just opens up a bunch of different windows so that you could flash more than one of these at one time. So if you were, like, I'm sure they have something similar when they're putting things out. Sometimes you buy these. In fact, the ones you have, I go and look. Depending on where you buy them from, they have different firmware. Sometimes they have the AT firmware on them. In fact, you used to, when you used to buy them, that's what they had. They had the AT firmware on it, probably not the version. The current version that is in the ones that you guys have is automatically connecting to a router that we don't have, and then it's trying to ping someplace in China to do a connection. So it's whoever set it up, they were testing to make sure the Wi-Fi all worked, and we don't have that router, and we don't aren't able to go and connect over to that. So we're going to just wipe it out. Okay, but by default, it's trying to do something, and they tested it, so your unit should be good and working because they pre-programmed it. Okay, and so we want to be in developer mode. Okay, so in developer mode, it opens up this kind of menued system, and it says, locate the ESP8266 IDF AT factory room bin by connecting on the 3 dots. So over here, there's 3 dots, and you click on that, and it's just going to bring up a browse. Yeah.
Does this firmware need to be flashed multiple times, or is it just like
one time? Yeah. One time till we wipe it out when we do some Arduino programming in the coming weeks, but one time on this go round, as long as it took. And so it says set the address to 0. So this probably comes up. So these different addresses here, when you download the AT factory, there is a factory directory, and it has just a binary in it. And that's what we're going for. It also has some different directories that have the different parts of it. There's the user code, there's the bootloader, there's a bunch of different things we put in at different addresses in the memory that's in this. So if you had your own code for the user part of the space in here, you could substitute that in, and then you put the different parts. And there's a README that says, oh, user1.bin goes at 3F000. If you have 4 megs of flash, it's at a certain address. If you have 1 meg of flash, and all of this kind of thing. So it lets you do all of that. And if you were saying, hey, I really need certain features, you can compile it in from the SDK, and you can set up this to program things in certain areas. We're just going to take the bin that they've given us, and we're just going to program it. And it's nice to have this option, because we used to have to, they didn't provide a bin, and we would have to grab the components and stick them at the right addresses. But what we do is we say set the address to 000. It probably is. We hit these 3 dots, you go find it. I'm in downloads, ESP8266 IDF AT2100, and then it's in the ESP IDF AT 2.1 factory, and it's called factory room. And again, we have the room chip, not the rover chip, because there's options sometimes that they'll have those, and it just has a different pin out from the board than what we're going to be needing. And it says match the rest of the configuration below. One of the things that has got me sometimes is you have to go over and you have to check this box here. And the reason for checking that is to say, do this. I can have a bunch of things in place, but not be testing something, and I can uncheck parts of it and not update certain sections. It goes through all the checkmark ones, and it will flash those, okay? So if I set all of this up and that's not checked, it will be back really quick because it didn't do anything, okay? So you have to check it. And again, I can have the different parts and then say, oh, I want to, I've corrupted something and I don't want to flash this one, but I need to flash the bootloader part and all of this kind of thing. So you can do that with this little interface. And then it says match everything else. And so when it goes and talks, it will talk to the chip and it should come back and tell you, for instance, the device ID, that it's got 32 megabit. And so we have 4 megabytes there of serial flash that's inside this chip. It's right in the CAN in here. So the ESP8266 is talking to the serial flash chip. And the crystal is it's saying is at 26 megahertz, and we want the SPI speed internal, so it's going to be running at 40 meg is fine. There's different modes of SPI, and the way the ESP8266, it's a dual data IO mode, not 4 times the speed. So we need to be on there. I think default it might show up there, but it's not really supporting that on the 8266. It's a way of getting data through the serial line faster. The other thing is there's a couple of different formats of the flash memory chip, and the one that we have is 32 megabit. There's, again, slightly different ways of interfacing, and so there's a couple of different options. So we just make all that match up. One of the things, there is a start here, and I'll go and click it. You have to drop down and make sure that it recognizes a COM port. You might need to go into Windows Device Manager and see where it is and see that it's picking the right one. I've had sometimes it seems to pick off that Bluetooth interfaces or things like that and not be picking the right one. So you need to make sure it picked the right one. And you just go start, and then it can take it a little bit of time, and then hopefully you get a green finish. And it says, hey, here's some different access, different MAC addresses for both an access point and for a station. So if I'm pretending I'm a router and I'm taking information so somebody can connect to me, this is going to be my MAC address. And if I'm a station, I'm trying to connect to a router, then that is going to be my MAC address. In the next few weeks, we're going to talk about IP and MAC and gateways and masks and everything, okay, and the way all of this kind of stuff goes. And so we'll come back. This is a way of uniquely identifying this in my local network. We'll get to all of it. Okay. So if that was successful, then this has the AT firmware on it. So when I reboot, it's going to set up and run the code. And what it's doing is it's going to set out, and just the way the 2.2 firmware, and there was a few different ones that did it, we programmed it through the USB module, and that's currently also what's being echoed out our transmit 0 and our receive 0. Same information that is coming out, the micro USB is coming out there. TX2 and RX2 is where you hook it up to another microprocessor. And so that is where it's going to give you give the AT commands, it sends them back to you. So they have it going like that because a microcontroller, generally, you wouldn't want to set it through a USB interface and then decode it back through the USB interface back to serial for another microcontroller. It doesn't make sense to do that. So they just pinned it out here. So I can directly connect it to another microcontroller, and this will be its Wi-Fi module and be able to send AT commands and do all of that. That's why they did it. Now in this go, I want you to actually on the keyboard type it in and see what's going on behind the scenes. So I want to actually connect it to a PC. But there's two options: either change the code so it redirects out here, and by default right now what comes out of here is log messages and error messages and things, so you could actually plug into it and have a look at information coming there at kind of non-standard baud rates. But I want to then, if we have this all programmed up and we plug that in and we did the flash downloader and it has the AT firmware in it, then what I want to do is hook stuff up to transmit, receive, and ground. I need a common ground to something else so that I can talk to it with my PC. Well, so what we're going to do is you have this module. And this module we're going to use in some later labs. And it is an ESP32. So it is one of these guys, but in a much different form factor. And so what they have on here is that ESP32 with a small OLED screen. And so we'll get that. It's an SSD 1306 OLED screen. And it has an SX1276 LoRa interface chip. And what we'll talk about this coming up, but what a LoRa interface chip does is it's kind of a standard around the world that allows you to send stuff quite a far distance, but low data rate and low power. So I could measure a water meter and once a day send out a chirp that could go, depending on how I have it set up, blocks to if I had something that was measuring something on top of Mount Doug, it could go for many, many kilometers on a coin cell, probably for a year, kind of thing. Low data rate though. I'm sending once a day, something. Yeah.
Does it use like FM or is it something completely different?
No, you guys are doing it's chirped spread spectrum. And so what it does is it goes across multiple bands. And so hopefully if there was noise somewhere that it puts all this, and it's dynamically able to adjust the bandwidth and the amount of data it sends depending on the interference and things it's seeing. You will talk about spread spectrum in digital comms next term. Okay, so but it's chirp spread spectrum, and so yeah, you should ask. Sahicha, do you have? Yeah, you should say, hey, we're talking about chirp spread spectrum. What is that? Yeah, that'd be good. But you guys will talk about it or spread spectrum anyway next time. So uh, you can't get something for nothing. It's great at distances, but again, very low data rate. And the idea is to, like in Munich, Germany, they have 7 gateways around Munich, and then they can have devices kind of everywhere, and you just send data. There's I'll talk more about it down the road when we do LoRa, but there's also gateways that have some of the blockchain transactional things. And for instance, down in LA and things, some people's routers have been making them a whole ton of money and things. Again, early people in make lots of money, but they also, somebody bought a $300 gateway and was making 60,000 a month because they were one of the first ones in a place that companies were using them and things like that. But there's also in the LoRa, there's something called the Things Network, which has worldwide gateways. It's all free to use. No one's kind of making kind of money on it, and you can connect up and send your packets and receive them from their back end anywhere in the world. So there's some kind of interesting stuff. So we'll come back to that. What I want to use it for right now is it's another microcontroller. Just kind of like I would use your Uno, except your Uno, for instance, is 5 volts, and most of the stuff we're working on is 3.3 volts. So I don't want to have to deal with that. So we're going to use one of our devices here. You have 2 different microcontrollers, a single core and a dual core unit. And so because I wanted to play with the ESP8266 first, we're going to use this as a serial to USB interface. So in order to do that, we need to disable the microprocessor because I just want to use the interface chip, because this one, for instance, here, programs here to talk to this 3.3 volt microcontroller. It's got the voltage conversion on it. And this here is a CP2102 USB to serial converter. That's what makes it nice and easy, and we just plug into it. Okay. The same thing is going on here. There is a USB to serial interface converter. I want to use that. We're going to use one or the other next term as well. When we talk to our Raspberry Pis, I want a logging terminal to go to the command line. We're going to use this as our interface as well. So it says the AT firmware uses transmit to and receive to for its commands. So that's where I'm going. I programmed it with this, but AT commands go here. And the LoRa module we're just going to use right now, even though it's a really capable unit and really cool, I'm just using it as a USB to serial converter. So in order to do that, I have to put the processor in reset, which gives it high impedance inputs, gets it off the line, and we just use the USB to serial converter. And so if I look here, it says the node MCU and the LoRa module connections. So the LoRa module, I want reset to ground. And so that's the thing here. I just need a pin to go from here, one of your DuPont connectors to go from reset to ground. And that's going to hold a micro in reset. And so all the inputs will be high impedance, and then I can just use the USB to serial converter. Okay, so just doing that's going to give that to me. Okay, same goes if I want to use the other one. For instance, same thing, put reset to ground. Now the processor's out of there and I can use the serial interface. Okay, but we're using it this way. So I'm connecting them together in order, I have 3.3 volts to 3.3 volts, ground to ground, and RX2 to RX and TX2 to TX. Now there's a couple things to talk about that. That's kind of weird that I put receive to receive and transmit to transmit. Normally, when you look at things, you hook transmit to receive and receive to transmit because you're transmitting out one, you want to receive to the other. And the problem, we shouldn't say necessarily problem, but serial communications, historically, there's two types of equipment. There's data terminal equipment, you're a computer. There's data communications equipment, you're a modem. And if you're data communications equipment, there's a straight through cable to go to the DTE. So they just used a straight through cable. And so in order to do that, transmit over on the other side, it's actually transmit to receive, it's a straight through cable. So if you have a DTE, you have transmit, receive, and I need a common ground, and you have DCE, data communications equipment, and this typically was, I think, 2, 3, and 7 on a DB9 connector, and that is going to be 2 is going to be receive, 3 is transmit, and 7 is ground. Okay, so on a DB9 connector, that's if you looked at the back of an old computer or you looked at a router or something, that's typically the serial connection, a 9-pin male connector on the back of a computer or a modem or a router or what have you. I saw Lindsay yesterday with a whole stack of network switches, and he was trying to come up with serial cables to USB to be able to talk to any of the machines now that don't have serial around, because there's still lots of serial data. You did serial with Wayne, right? A little something?
Yeah.
You know the transmit, you have a start and you have 7 data bits. Yeah. No stop bit, maybe even parity, no parity. Okay, so I wanted to, we'll talk a little bit about serial coming up. So IBM way back when said data terminal equipment, data communications equipment. They had the DB9s, they had DB25s with all sorts of icky connectors before that, but it went down to DB9. And so we had, if I hooked up a computer to a modem, which is what I normally wanted to do, I just had a straight through cable. So on the transmit, on the data terminal, there was a receive on the data communications. So straight through cable worked. What happens if you're trying to connect two things together, two DTEs? Well, if you look at a DTE and a DTE, then you have 2 is transmit, 3 is receive, and 7 is ground. And then we need a crossover cable. Okay. The ESP8266 followed the Arduino interface, which means that it's like a data communications equipment, not data terminal equipment. So when I send out a transmit on the DTE, they actually labeled this transmit, which meant it was a DCE, which meant incoming was going in there. This DCE says, I'm accepting the transmission. So they labeled it transmit, even though it's receive in the way you would normally think about it. Okay, so data communication says, it's received, so I'll label the pin transmit because I'm expecting transmission from somebody else. Okay, and so this is saying it's going to be transmitting there. So I am wanting to have the receive. So long and short is sometimes you hook stuff up and you get nothing because it needs to be this. Because are they labeling it so it's data terminal equipment, or am I labeling it so it's data communications equipment? Arduino's is, so these guys hooked it up like it's a DTE, and these guys hooked it up like it's a DCE. So receive goes to receive, even though what's really happening is transmit is going to receive. Confusing. So what happens is, and when you're dealing with serial, and if I look at the back of a switch or a router, for instance, I don't know what they have. It's probably data communications equipment of one of those, but sometimes switches are data terminal equipment. So you have to look and say, am I getting any transmission? You might have to flip the wires around. And they used to have, well, they still have, but little breakout boards that show you lights flickering and showing where the transmit and receive happens. You can pin out the wires and try and figure it out. And the reason I kind of talk a little bit about this is I've had project students, for instance, get hung up for days because you just can't get a serial line going because you have some equipment that they were trying to interface to that still has a serial port and just trying to figure out transmit, receive, and ground. Okay, and so it's going to be this or it's going to be this with the ground still, right? And you just might have to play with it. The other thing to go with that, once you have that, is am I getting garbage? Okay, and if I'm getting garbage, but I'm getting stuff, then your baud rate is wrong, okay? Or your parity bits or all of that kind of stuff is wrong, and you have to play with that. And I'll talk a little bit about baud rate and the thing that you should be seeing on a serial port coming up as well. Okay, so that's a long kind of way around saying, hey, I need to hook up receive to receive and transmit to transmit, because you're not really doing that. One's a transmit and one's a receive, okay, but it's the way they labeled it. All right, the other thing is I have 3 volts to 3 volts and ground to ground, and it says only plug the USB from your PC into the LoRa module. Okay, so I plugged into this one and I programmed it as AT firmware. Then I unplugged it. Then I put this into reset mode to get that processor out of there because I'm just using the USB to serial interface. Then I hooked up my receives to receives and my transmits to transmits, and then ground to ground. I need a common ground and the 3-volt lines. And if I have the 3-volt lines hooked up, I've got it hooked up here and I've got it over to here. So that's what's powering it up. I don't want you plugging in the USB on both of them because your regulators on the chips aren't going to like that because I'm trying to power 5 volts down here to the 3 volts, same with on here, and those 2 regulators will see that, okay? And we don't want that. So if I have those going, I can plug in if I want to do something. You pull the 3-volt connection from here off of the one that's here, there, right? Pull that wire. Then I can common grounds and I can program them, plug them both in and have them both work if I want to see what's going on, but I don't power them up with the 3 volts at the same time. Yep.
Sorry, so we're sending data into the LoRa module through the serial to be distributed on the Wi-Fi chip?
Yes, okay. I'm using this as USB, so I plug in USB to serial. It's going out these pins, it's going in these pins, and then I'm going to have on a terminal like TerraTerm, I'm going to be able to see data. So I should be able to go AT, and it should go back okay at 115.2. Okay, 8 data bits, 1 stop bit, no parity. And again, this, if you plug in more than one unit, do not have the 3 volts connected. Okay, but if I'm only having the one plugged in, then I want to plug it in. So right now I can plug this in. This is going to power this chip, and then we're all good, right? So that's the way I have that wired. Okay, if I want to, and in fact I've got it so I can't plug this in because I've plugged it nice and close to it, so I can't accidentally plug in two. You know, if I wanted to have them both to see what's going on, then I would make sure that my 3 volt from this chip is not connected to that chip. Almost there. So this is what it looks like. Tried to take some pictures of that so you could see how it's going. So we're just plugged in over on this side, powers up this, this one powers up this, and we have our transmit and our receives going over there. Just another picture of it. Now, using the Arduino serial port monitor, Arduino's done a nice job of having the serial port where sometimes you have to go into device manager and you go, what darn COM port was it that it came up and all the rest? Arduino's pretty good at if you go under the device and go to ports, it pops up and it says, here's the ports I see. And so usually it will then say, hey, this one is either an unknown, or it'll say that it's an Arduino, or it'll say, you know, all sorts of different things, or it'll say it's Bluetooth, for instance. And so it says, using the Arduino, select the USB module and type in serial commands. So I am at 115.2. And the other thing with the AT command set is it wants to see the carriage return line feed. So in order to recognize that it was an actual command, you need to make sure that carriage return line feed is set. So every time I type a command in the top and hit enter, it will do that. TerraTerm works for this as well. It's not as good at guessing what COM port and things. You might have to go into the device manager and see what's there. And then if I type AT and either hit enter or hit send, as long as this was connected up, it should say OK. And then if I type AT plus GMR, it's giving me the version number. It should come back and say it's AT version 2.21 as of August 6th, for instance, 2021. That was the last time it was compiled from the binary that I grabbed. Software development version 3.4.37. Again, you can download the whole SDK and compile things yourself and do that kind of thing. We just grabbed the binary. And then again, 2.21, and it was the room version, not the rover version that we got. If we got there, awesome. The firmware is successfully put on there. I've had some times where if it just starts scrolling stuff, it didn't program right. As soon as you plug in, all you see is a bunch of garbage going up the screen. Something went wrong. Typically, the binary, it's been pretty good, but sometimes I've seen it where if things aren't in the right memory space when we had to do it individually. But I have had it not take sometimes on this one. And you go back and you program it again, make especially sure that all the rest of the stuff down below to talk about frequency and type of memory chip are the ones that I selected. And that should work for you. If those aren't right, it will just scroll garbage because it didn't program in properly. Okay. And so it says, if AT and AT-GMR work, try AT plus CW lap. Okay, and so there's another one to go and try. And so it's an AT command, and over at Espressive in the docs, there's a list of AT commands, basic AT commands to do networking, to set up a little web server, to do all sorts of different things, and we just in the command line type it in. AT plus CW lap is list access points. So it should give me a list of all the routers it finds, and it is pretty good at finding them, okay? And so it will list them. So you should see a whole after a second or two, you should see a whole list of all of the ones it finds down there. We will continue on with this next day. There's a whole bunch involved. From this point, we have the firmware on, and then we can start playing around with actually sending data, connecting to the internet, connecting to routers, doing all of that, just using our command line. Thank you.